Hello, we're going to do an example of a gradient descent algorithm on this particular problem. Now, gradient descent would never be done by hand like this, except for students trying to understand what gradient descent is. This is really an algorithm that we want to have a computer do for us, and we will. We will soon have the computer do this for us in our lab. But it's a good idea to see the algorithm on a problem by hand as well. So in this case, we have a function, we have a surface here, and it's something of a bowl. It's not a paraboloid because this is a fourth power, but otherwise it kind of has a bowl shape. And the minimum is at the bottom of the bowl at 4, 3. So we already kind of know what the answer is, and we're going to watch gradient descent get us there. So we're going to start at 5, 2. We'll use an alpha of 0.2, which is something we get to choose when we're running this algorithm. And we just want to do a couple of steps of this thing. So the algorithm says that our x1, our next guess, is going to be x0 minus alpha times the gradient of f at x0. So we evaluate the gradient at our point, and we take a small alpha-sized step in the direction of the gradient, and that's how we change from x0 to get to our next guess at x1. So basically, we're going downhill in the steepest direction at every step, and we're going a step with size alpha, which we get to control. All right, so we do need the gradient, and the gradient of this function is the x derivative is just x minus 4 cubed. The 4's cancel. And the y derivative is y minus 3. So we have the gradient. We evaluate that gradient at our initial point, 5, 2. Actually, just throw it into the whole equation here. We have 5, 2 minus 0.2 times the gradient at 5, 2. So if I plug in a 5 for x here, I have 1 cubed, which is 1. And a 2 for y, I have negative 1. So multiply this vector by 0.2 and subtract it from this vector, and our x1 vector comes out to be 4.8, 2.2. All right, so we need to do one more step. We'll make some space for that. All right, we have our x1. We started with an x0 initial point. We've done one step of gradient descent, and we took a little step downhill and ended up at this point. We're at the point 5, 2, and we've ended up at 4.8, 2.2. This is a little step down the hill towards the minimum. To know if we're done with gradient descent, we do, before we move on to the next step, we do want to check the gradient at this point. So the gradient at x1, right, we have the gradient. It is x minus 4 quantity cubed. So 4.8 minus 4 quantity cubed is 0.8 cubed. And then the y component was y minus 3. So 2.2 minus 3 is negative 0.8. The magnitude of the gradient at this point is what we use to decide if we've hit the bottom, if we've hit our minimum, if we're done, or if we need to keep going. So in this case, the magnitude of this, we know how to compute the magnitude of the vector. So I've gone ahead and computed it. It comes out to be 0.9498. This is not close to 0, so we keep going. We do another step of gradient descent. So the next step is our x2 vector is going to be our x1, 4.8, 2.2. minus alpha, 0.2, times the gradient at 4.8, 2.2. And we've got that gradient right here. So that's 0.8 cubed, minus 0.8. This is just punching numbers into a calculator here. And what we end up with for this point is 4.6976, 2.3024, and the magnitude of the gradient at this point turns out to be 0.776 Okay, so it got smaller, which is a good indicator that we're going in the right direction. We're doing the right thing. We've done a couple of steps downhill. It's not going very quickly, right? This could go faster, but that's okay. We just picked an alpha of 0.2 and it's going downhill. It's going in the right direction. Now, if we wanted to, we could continue this process. We just find an x3 based on x2 and then an x4 based on x3. And eventually this is going to converge to the minimum, which is that 0.4 comma 3. And you can see us getting closer to that point as we go. So that's a quick example of gradient descent on a specific problem. Like I said, we would do this by hand, and we will do it in class and probably on a homework problem by hand. But really, we want a computer to be doing this work for us. This is very algorithmic and something that a computer would be happy to do for us.